In today's video, we'll be talking about the hypergeometric probability distribution. Well, what is the hypergeometric probability distribution? It's the probability distribution used to calculate probability under discrete variable. What are the conditions that we have to use? We have to apply so that this probability distribution can be used. There are two conditions. Right, the first one is the result of each draw can be classified into one of two mutually exclusive categories, and two, probability of success changes each draw. And that means that highly likely in the question, when they say that there is no replacement whenever they draw something, let's say they draw 5 apples and there are green and red apples. If they say they are drawing without replacement, highly likely you can be using this probability distribution, right? Now, these two conditions need to be satisfied before we can use this hypergeometric probability distribution. And thus, what is the formula of the hypergeometric probability distribution? The formula is quite simple. It's not that simple, but it's easy. I will understand. Right. First, the probability of x equal to a certain number. X is the event of something, equal to R, which is the number of successes in the population. Choose using the combinatorics, X number of successes in the trial, in the n trial, n minus R, which is the total number of elements in the population minus the number of successes in the population. Choose n minus x, which is more n minus x, which is the number of trial minus our number of successes in n trial divided by capital N. Choose n. Now let me define each of them for you, right? So R in this case is number of successes in population. Let's say you have, returning to the 5 apples, if there are three green apples and you're trying to choose the green apple, there will be a total number of 3 successes in the population. Then X is the number of successes in n trial. This means that, let's say you wanted to find the probability that you choose 2 out of 3. So in this case, the number of successes in n trials is 2, right? Then we have capital N, which is the total number of elements in the population. And this means that, well, we have 5 apples, so there are 5 elements, right? And the small n is equal to the number of trial. This means that out of how many trials do you want to find the probability of picking 2 green apples, for example, right? And this is the formula to find the probability. And beside that, we also have the mean, which is the mu equal to expected value of x. denoted by the formula n small n multiplied by the R divided by big N, where small n is the number of trials, R is the number of successes in the population divided by big N, which is the total number of elements in the population, and of course the variance. In this case, you noted that sigma square equal to var x. This formula is a bit complicated, but should be okay, alright? N multiplied by R over N, which is the mean, multiplied by 1 minus R over big N, multiplied by N minus small n divided by big N minus 1. That is your formula for the variance. This formula can be easily applied into Excel or R if you ever use those in calculating statistical probability using technology, but given that you are using it in academia, I mean, this is the right formula. Anyways, now let us move on to solving example questions, right? Okay, a committee of 8 members is to be formed from a group of 8 men and 8 women. If the choice of committee members is made randomly, what is the probability that precisely half of these members will be women? Right, so we can start denoting. Remember our formulas here on the hypergeometric probability distribution. Our formula is P probability of success equals to x that we want, R C x n minus R C n minus x divided by n choose n, right? Now we can start denoting, right? So a committee of 8 members is to be formed. That means there will be a total of 8 trials, right? So our trial, our n, small n, number of trials will be 8, right? Then what is the problem? Then from a group of 8 men and 8 women, right? That means there are how many people we can choose from in total, which is the big N, and that is going to be 16, right? 8 plus 8 is 16, so 16 people in total. Then if the choice of committee member is made randomly, alright, what is the probability that precisely half of this member will be women? So what are we trying to find? We are trying to find that half members are women. That means there are 4 out of 8, right? So there are 4 women, that we pick 4 women, right? And now we want to know how many successes are there in the population of R. And that will be 8 women in total. There are 8 possible successes in the population, and we want to pick 4. Now we can just easily apply this formula, right? Probability of x is the amount of women, equal to, we have 4 women, RCX, that means 8 choose 4, RCX, R choose 4, multiplied by n minus R, 16 minus R is 8, choose small n minus x, n 8 minus 4, divided by big N, 16 choose small n, 8, 6, 8. And then all you have to do is to input that into the calculator, and you will get 490 over 1287, which is approximately equal to 0.3807. And that means that it's a 38.07% probability that half of members will be women. Moving on. A bond analyst was given a list of 12 corporate bonds. From the list, she has selected 3 whose ratings she felt were in danger of being downgraded in the next year. In actuality, a total of 4 of the 12 bonds on the list had their rating downgraded in the next year. Suppose that the analyst has simply chosen 3 bonds randomly from the list. What is the probability that at least 2 of the chosen bonds will be among those whose ratings were to be downgraded in the next year? Right? Calculate the mean and variance. Right, let us analyze this point by point. Let me just recap the formula here. Probability x equals to x equal to r choose x, n minus r choose n minus x divided by n choose n. Right. So there is a list of 12 corporate bonds. Right? It means there are total number of elements in the population, n equals to 12. Right? From that list, you selected 3 whose ratings you felt were in danger of being downgraded in next year. That means there are going to be 3 trials in the population, right? 3 number of trials. So our small n is going to be 3. In actuality, the total of 4 of the 12 bonds had their rating downgraded in the next year. That means the probability of success in this situation is 4. There are 4 out of 12, right? Total number of successes in the population is 4. Now, suppose the random analyst has simply chosen 3 bonds randomly from the list. Now, what is the probability that at least 2 of the chosen bonds will be among those whose ratings were to be downgraded in next year? So what are we trying to find here? Probability that x at least 2, right? Success is at least 2. That means 2 or more. And this could be easily denoted as 1 with the total. I mean, we could easily calculate 1 by 1, 2, 3, 4, but it will be easier if we just use 1 minus the probability that our x equals to 0 minus probability that x equals to 1. Yeah, and that will give you your answer. So, in this situation, we take 1 minus probability of x equals 0. Well, 4 choose 0, n minus r, 12 minus 4 choose n minus x, 3 minus 0 divided by big N choose n, 12 c3 minus 4 choose 1, 12 minus 4 c3 minus 1 divided by 12 choose 3. And that will give us the answer, which is, and you'll get 13 over 55, which is approximately equal to 0.2364. And then calculate the mean and the variance, right? We want to calculate the mean and the variance. So calculate the mean and the variance. So our mu, or our expected value of x, remember, is n r divided by n, right? So it's equal to 3 multiplied by 4 divided by 12. And you will get 1. And then our variance, equal variance x, sigma square equal variance x, equals this nasty formula, n r divided by n, 1 minus r over big N minus small n, big N minus 1. And just substitute the formula, 3, 4 over 12, 1 minus 4 over 12, 12 minus 3 divided by 12 minus 1. And you get 6 over 11, which is approximately equal to 0.5455. And that's your answer. Overall, if you want to really understand this hypergeometric probability distribution, first you have to know the condition that they satisfy, and then you have to obviously know the formula so you can apply that in the right situation. And that's it for the video.